Now. Okay, welcome everybody. It is Wednesday, August 3rd. The gates are open. It is another beautiful day, hopefully not 100 today. We have been having some unique scenarios with brush fires and all kinds of nice things going on in Texas because of the hot weather. We have a great guest today, and before we get rolling, let's have our own John Sibley Butler play some music.
Mr. Record Man, I'm looking for a song I heard today. There was someone blue singing about someone who went away. Just like me, his heart was broken by love that used to be. So lonely song about a lonely man like me.
All right. Thank you, John. Very nice. Very nice. I like that one. John Butler, how are you, sir?
I am fine. The world is very, very interesting for those of us who like to study the world. And it looks like the uncertainty and the unpredictability and the opportunity is great, very, very great now. As we look like we are migrating to a distributive workplace where people are trying to decide whether or not they want to work or not. I'm reminded of the essay that appeared in Texas Monthly about how wealthy people were moving to small cities and we could work, quote, anywhere we want to work. And then, of course, the stock market is going up and down and up and down. And the world, of course, is very interesting. What's going on in China, what's going on in Taiwan, what's going on in Europe in terms of the war. There's a lot of stuff going on, but there's a lot of opportunity for companies. It's interesting. We all went to Zoom during these times, but Zoom was not designed, right, for us to teach or have business meetings. We just made a lot of good practices out of it. So I look forward to the day as we tune these kinds of technologies up to meet the future. But it's a lot going on, and then you have the economy going crazy. The inflation is there. But then, are we in a recession? Maybe we're not. Maybe we are. So it's interesting times for the predictors of the world, for those of us who look at the measurements of what does it mean to be in a recession. Well, it's just a measurement, it's a number. So we're having a lot of conversations about what that means. So it's interesting times.
Absolutely. Llewellyn King, how are you, sir?
Well, I have had or have breakout or breakthrough COVID. Linda and I came down with it a week or more ago. I was down in Washington to give a speech, and I came back and was sick, and I've been sick ever since. Nothing terrible. It's and we had our 4 shots, so we're immunized. It's just like having a bad cold for a long time. And anyway, besides that, we're in good shape. The world is not in good shape. That the world is a rather strange place in which we have huge progress in many directions, scientifically primarily, and social regression possibly, and the regression in international affairs. So you have 2 very powerful forces, the scientific evolution of mankind going on at a huge pace, and the regressive things happening, whether it is the old-fashioned grab for another country taking place in Europe with Russia and Ukraine, or the pettiness going on in Asia or over the Taiwan between China and the rest of the world, and China and the island of Taiwan, which does not want to be an integral part of China. And we are facing an election which will be fought on the wrong issues. Will be fought almost entirely on the social issues and the social divide, and not on the great issues facing the world. The big hump we have to get over, and it is a massive hump, is this winter when Europe is going to run out of fuel, and we're going to be called upon in various ways to help Europe financially and with all the technology and all the available liquefied natural gas and product, i.e. kerosene, gasoline, diesel, that we can send there because Russia is likely to cut off all supplies especially after natural gas, of diesel, which is very critical, of course, in transportation. Meanwhile, we are seeing amazing things. We're seeing the incredible space telescope, which shows us what happened billions of years ago. We have evolution on every front, but except that we're not going that way. We're going to have the wrong issues before our own election, and we look forward to a rather difficult political situation in the United States next year, where we're likely to have at least one of the two houses of Congress in the hands of the Republicans, keen to stymie the president at every turn and increase his appearance of impotence. And of course, that is not good as a general proposition in a time of crisis. But after that, we're also in a great change. You mentioned, Johnny mentioned how we work, but we're also going to be in a change about what that work is. We're going to start seeing automated transportation, particularly intercity trucks and things like that. That will throw a lot of truck drivers elsewhere into the labor market, gasoline station workers. But I don't think that's a problem, because there continues to be and appears to be no solution to the need for manual workers to do repair, construction, maintenance work. Indeed, the demand for them, particularly if they're craftspeople, if they can do such things as plaster stone cutting, metal fabrication, and indeed there may be more work in construction than we can conceive of, because with global warming, sea level rises will continue, and we'll have to build substantial civil engineering structures to keep the sea out of many cities and other places. So there'll be plenty of work. I've been reading my friend Harold Myerson's rather dismal accounts of the market for labor in the future, but I think he talks to too many trade unions and is out of touch with the real demand, and the demand that is going to appear. It's already there for workers. We have to get through this winter. We've got to get through our own political crises, which is a crisis of ridiculous division in the country, and things will work out if somebody doesn't do something foolish, like extend the nature of the war taking place, or a new war is not unleashed somewhere else, especially in Asia.
Got you. And Llewellyn, you are in Rhode Island today, right?
That's correct. Well, I woke up in Rhode Island, and as this marvelous age of technology has not evolved quite to the point where I can be transmuted somewhere else without knowing it, I might otherwise be in Paris or on the Amalfi Coast, or even in somewhere lovely in South America. No, I'm in Rhode Island, which is pretty remarkably lovely itself. We suffer from something here, the sense of being on vacation all the time, because it's pretty, it's laid back. You have to drive for 20 minutes in any direction, and you reach a different kind of topography. You're at the beach, or you're in the hills, or you're in a forest. It's really a
all these want to be Texas. Everybody wants to be like Texas. Can drive here and
you know, my dear boy, when I see that the temperature is north of 100 degrees, the electric supply is loosey. I don't want to be in Texas at all. When I see the strange social constructs going on, I wish to be very far from Texas, and indeed maybe not admit that I know any Texans.
Oh,
lest I be tarred with their.
Let me set the record straight. That
Thank God, Johnny, that you are a Louisianan.
Well, when we buy y'all, y'all know where you are.
Let me just set the record straight that all of you.
I got to tell. Isn't there a story?
Llewellyn, hold on. Let me set the record straight that all of you outside of East Texas or West Texas, it's just where you are. You're in East Texas, so don't get excited. Let me go to our guest because he's waiting patiently. George, how are you, sir?
I'm doing great. Doing great.
Educate us real quick, because I would say your last name a certain way, but how do you say that powerful name of yours?
So it's properly pronounced Bjelovuk, but my father decided in the 50s that most Americans won't be able to say that very well. So I think people have been saying Bjelovuk for years, but either way works.
Bjelovuk. And where is the heritage of that?
My father was born in Bosnia.
Nice. That explains why you're such a smart guy.
Or hard-headed, one or the other.
Or both. So for those of you listening that don't know George Bjelovuk really well, I happen to have the fortune of knowing him for a long time. George is currently the vice president and evangelist of next generation grid software at Siemens. He's going to be with us for the hour. George, prior to that at Siemens, was also the VP of Energy Solutions for a couple of years or so. And prior to Siemens, he was a principal at his own consulting firm, and he was a program manager at American Municipal Power, and he was a senior manager at E&Y. But the extent of his career, really, and how he gets kudos everywhere, is because he worked at American Electric Power for over 30 years or so. And his last gig was as a managing director of enterprise software and systems and the like. And he also has another good credit, which is him and I happened to did a lot of work, and happen to still do a lot of work on this whole thing called the smart grid. And he was actually the original driver of the American Electric Power Grid Smart program, which, you know, as I was reading some stuff about it, it's brought so many memories back, George. George holds a BS in electrical engineering from Youngstown State University and an MBA from The Ohio State University Fisher College of Business, and also has a certificate in business administration and management development program from The Ohio State University. Welcome, George.
Thanks, Andres. It's great to be here.
It's awesome to have a Buckeye on the court here, John Butler, because, you know, UT and Ohio State has had this interesting offset rivalry. And I remember one time I invited George to come down, and there was a game going on in town, and he brought all these Ohio State jerseys. It was quite epic in the stadium.
Well, you know, I went to Northwestern too, so my wife went to Northwestern, so we enjoy Ohio State, but also with the LSU, which is a real league, and we do play those high school leagues sometimes. That's called the Big Ten.
I knew that wasn't going to take long. Johnny, I will say that there are probably some friends of mine that still work at, or that are still at Southwestern Electric Power, SWEPCO in Shreveport, Louisiana, and they'll remind me often of the bet I lost when LSU beat Ohio State in the Final Four, and I had to wear an LSU hat to a top management meeting at AEP, and I think my friends in Shreveport never let me live that down. So.
Yeah, but Benny Wells went 60 yards on the first play. You can always remember that.
Yes, sir.
Anyway, George, you see the world from a different perspective. You work for one of the largest multinationals in the space. Phenomenal company. You guys have a global presence. You are one of the five horsemen of the energy market, as I call them. What say you about a post-COVID world, probably accelerated by COVID and all kinds of things, and what's really going on in 2022? How do you see what's happening right now? Is the market good, bad? Is the economy good, bad? What's the outlook for Siemens?
Well, first of all, I'll say that I think we're starting to see this acceleration that I think Llewellyn referred to. We're seeing that firsthand in some parts of the world. It's fortunate for me to be working for a global firm that's got the reach we do, and we actually have access to the markets globally, and we start to see things in places where we might not sort of expect them in the United States. And so having access to the customers in Europe or customers in Southeast Asia, where we start to see these impacts, manifest themselves at a much faster rate than we see here in the US. I mean, I think the speed of the change, specifically on the distribution system, and I'll talk a lot about that. I think the speed of the change of what distribution operators are going to have to deal with here in the near term is largely underestimated. I mean, I think I've seen statistics that suggest that we're going to see like a 7-fold increase in DERs by 2030. Think rooftop solar and Tesla Powerwalls in people's basements. Well, I think EVs specifically are expected to grow 5-fold by 2025. I mean, that's like tomorrow.
Mhm.
And I honestly think that the impact of this change just really requires much more agility than today's software providers can enable. And I think it's one of the reasons why we formed our next generation grid management team, while we're spending a lot of time sort of out in front of the market, describing what we're essentially sort of behind our closed doors working on and rolling out here to kind of be prepared for this onslaught of requirements from our customers.
Yeah, well said, well said. Real quick, George, I wonder if you guys, I saw an announcement that is really interesting to me, and perhaps the audience. DEWA announced the launch of the very first, according to them, automatic smart grid restoration system. I assume this is a ADMS SCADA on steroids. I'm wondering if that's your software. Just curious about that, but I thought that was an interesting announcement. DEWA, the Dubai guys are always saying they're first on everything. So what say you about that announcement?
So I'm not familiar with that particular announcement, but I will say if you walk the floor at DistribuTech this year, we kind of joked that the over/under on the use of the word DERMS was probably 60, right? There's probably 60 vendors on the floor that somehow featured this term DERMS. And this concept of centralized control and decentralized control and orchestrating and coordinating how self-healing grids or self-healing intelligence at the edge might be coordinated with sort of some central control authority is kind of a emerging topic. We saw that at DistribuTech in a number of places, and I think that's probably describes where folks are going, where folks are thinking about going.
Yeah, Llewellyn, you ready to jump in?
Well, yeah, I'm always sort of asked more or less the same question these days, and that is, are we going to have enough power generation? We can't do it all with software. We can't do it all by managing DER. If you're going to have the kinds of increases in demand, which electric vehicles alone are going to mandate, we're going to need to generate a lot more electricity as well as move it around more efficiently. And I wonder whether the plethora of small utilities that we have in this country, not the big ones like your former employer, but all these little ones, whether they will get on board fast enough and whether they have the resources, and particularly the GMTs in the rural electric cooperative movement. There are about some incredible number of them. Altogether, I think there are 3,000 utilities, 2,000 claim to be public power in all of its dimensions, from TVA down to a little municipally owned system. But you also have 1,000 rural electric cooperatives, most of whom are just distribution companies. So those that are generating or buying in from large generators are going to be looking desperately for power supply as these demands go up. And the favorite subject for our host, you may know, is the Ford F-150 Lightning. He thinks one is going to arrive at his home and it's going to transmute life's leaden metal into gold, that everything will be different thereafter and superior. I suspect he'll be pipped to the post by Toyota, but that's just a guess. But we've got tremendous demand building, and I don't think we have tremendous construction of the kind of power we'll need. I think it's very, and this, I'm not phrasing this as a question, but I mean it as a question. And the question is basically, am I right? Are we building enough in concrete and steel, or are we relying too much on software?
Well, no, Llewellyn, I'll defer the discussion on the adequacy of the generating supply to folks that sort of work in that part of our business. I mean, we've got an entire Siemens Energy business that might be able to speak, at length about those topics. I mean, I'll share my own perspectives in that. You mentioned 3,000 utilities in the U.S. I mean, and again, my focus lately is on the challenges these distribution operators are going to have from managing if Andres' dream comes true and we all have a Ford F-150 in our garages, and we all have to charge that thing and ultimately have rooftop solar on our roofs. These distribution systems are going to have to fundamentally change, not just in infrastructure investment required to make them reliable and maintain voltage and clear faults during storms, but to be able to support all this electrification. I mean, you're absolutely right, Llewellyn. I mean, the things that we've historically done with fossil fuels, we're being driven to do electrically. So you see things like advocation of more heat pump heating and cooling. You see more advocation of electric tow motors in warehouses and electric tugs in airports. We're displacing fossil fuels at every juncture. And yet it really does beg the question of can the central supply keep up with that? And so I defer that question to others that have a perspective on this. I just would make an observation that organized markets in the U.S., I think, have done a pretty good job. We'll leave Texas out of this, Andres, but I think the FERC would argue that the ISOs and the planning that generators, the supply demand planning that's been happening, post FERC Order 888, I think has really enabled some much better transparency about what we forecast our loads to be and what we ultimately will need from a supply side standpoint. Now, where that supply comes from ends up being a debatable topic, I suspect, for a different day.
Yeah,
But George, let me get to something in your wheelhouse. Wouldn't you say that we have 2 or 3 decades of great research? If you look at what EPRA has been funded, that's sitting on the shelf that could actually take us forward for the maintenance and looking at how we control the grid. So there's a big gap between working with 1925 technology, where things are plugged together now. And the question is, what will it take to take the technology off of the shelf to inform all of the individual companies, all the utilities, that they've got to switch from 1920 technology to all of the stuff that EPRI has been funded and is now sitting on the shelf. So my question to you is, in your technology transfer tradition, what the hell has been happening with all of the EPRI stuff that's sitting on the shelf?
Well, again, I won't speak much to the work that EPRI does. I mean, I chaired the EPRI IntelliGrid committee for a number of years when I was at AEP. I mean, the organization does great work. But Johnny, I'll actually pose this as a sort of a stake in the ground that I think all of the technology that we use today in these distribution businesses is grounded in, I'll call it legacy architectural design. So if think about how software products are developed, the databases and integrations required to make them work, they're really grounded in the technologies that have been in place for decades.
Right.
And the proposition that Siemens is making now in this grid software announcement we made on May 5th is that there's a fundamental change required to the way these software products work. If you think about building things in a cloud native manner and in a way that allows these applications to scale on demand, the use of things like containerization it really is absent in the large part of the operating technology the distribution utilities use today. And it's our intent to bring those products to market in a way that utilities can adopt them in a much easier way, simpler to deploy than buying like the next big monolithic ADMS system from somebody. We want to roll these products out in a modular, agile way that really react to the needs of our customers. And you're aware, both of you guys mentioned the number of utilities that we have in the US. Those big guys that are 5-6 million customers have fundamentally different sets of needs than that co-op in Florida that might have a different set of needs and priorities in the near term. And it's our intent to address those in an agile manner going forward.
But George, I like to say that the grid is where computers were 50 years ago.
Yeah.
Everybody's on a different kind of software, and just look at Microsoft, it standardized everything. So the standardization on a cloud somewhere that would allow us to know where every piece of electricity is, and we'll be able to manage that. And I don't see anybody, I guess you guys are doing that, except maybe Grid Pathway and the guy that I'm working with. that's really trying to solve from the grid edge in and solve all of those issues. So it's very interesting to me.
So George, go deeper a little bit. So when you think about the architecture of the utility, right? An integrated utility, PG&E, American Electric Power, any of those guys, you got, generation, transmission, distribution, metering, customers, and a bunch of systems underneath that. So you got SCADA, EMS, DMS, so on and so on. But what does this announcement mean in terms of those systems? Are you replacing them? Go deeper in that.
Yeah, so Johnny, you couldn't have served as a better setup guy for me than what you just did. I mean, at the end of this announcement that we just made on the 29th of June, I'd kind of point folks to our press releases and do a little deeper dive on our website, right? So this Accelerator announcement that we made isn't just in grid software. It's across the entire Siemens portfolio of products, right? From digital industries and industrial automation to building technologies to train management systems and including grid software. And, our concept is, look, we want to build an ecosystem that allows there to be a curated portfolio of products, whether they're ours or our partners. And, we just recently announced the partnership with Esri. We keep stay tuned. We're going to basically announce a few more as we're going through the year. Our intent here is to create a marketplace that, so to your point, Johnny, that everybody's using like some different piece of software. Our intent is to allow those products to work together better than they ever have before and give customers a place to go get them, knowing that this portfolio is curated, it's validated. If you get into the nuts and bolts, the APIs have been tested, and we know that things are going to work together. You don't have to hire a big integrator to go stitch this thing together with a big integration project. I mean, that's our vision for where we want to move where we want to move our products, not just in our business, but across the entire Siemens software business.
Wow.
Well, I think that's what's needed for the grid, because although they might be of different sizes, I mean, there are some companies that have 3 computers and some companies have 5,000 computers, but they can all pick up what they need to get the job done. And I think as we move forward and look at the integration and get away from, I don't know how you're going to have to change the engine while this big 797 is flying. And I think that's the issue you got to do. You got to check, because Llewellyn wants his lights to come on all the time.
So, no, I don't live in Texas. I can do without air conditioning for a short while.
Oh gosh.
So George, real quick, give us a perspective of a bunch of things. How important is for this vision of the future in an integrated power grid and the infrastructure that you're discussing? How important is connectivity, broadband, fiber, 5G? How important is that?
That's an interesting conversation. We talk to utilities that already have DER penetrations, and I'll just generically refer to DERs as rooftop solar, residential or distributed storage, and electric vehicles, sort of all lumped into the DER thing.
Mm-hmm.
And if you think about it as the transformation of the loads that have historically been behind the meter, sort of at the end of our distribution systems. We're talking to utilities today where the connected generation, distributed generation behind those meters exceeds 100% of the rated capacity of those feeders. And you think about, well, utilities would say, well, I don't have to worry about this until I get to 30 or 40%. 100% is right around the corner. The ability for these systems to generate and backfeed energy into your transmission system through your distribution substation is almost here today. And so the real challenge that we see is this concept of investing in infrastructure, going through the regulatory filings and prudency reviews to say, I need to do distribution automation investment in some part of my system, or here's my 20 worst performing feeders. You present this to the regulator, say, here's my remediation plan to actually get these off the list next year and show you a different list of 20 feeders. Mm-hmm. Those infrastructure investments are only going to keep up with what we think is maybe 10 or 20% of what's really going to be required by, pick a date, 2030, 2050. The rest of this is going to have to come from software. We're going to have to work on communicating with these assets in a way that we've never thought possible before. And you bring up this question about what's the role of broadband and 5G and private VPN into these assets. There's a pretty active debate about whether or not we do or don't need RTU-like access to every connected endpoint on the system. I mean, there's there's some pretty cool, AI and machine learning that we're seeing coming out of our labs that we've demonstrated to utilities in Europe, where we can actually do some, basic build algorithms and do some machine learning to actually forecast the behavior of these distributed solar plants, connected solar, rooftop solar, in the absence of telemetry, right? In the absence of near real-time data coming from these endpoints, take irradiance forecasts and weather forecasts, apply them on historical behaviors of these endpoints. We can do a pretty good job describing and behaving what's happening on that distribution system without all the instrumentation that I think people have conceived up until now. So this is really going to be a fascinating evolution, I think, in the next 5 to 10 years.
Well, let me ask you this: the U.S. government has a $60 billion budget in this for this grid pathway, and that's a good question. What as we start to do regression equations and predict things, I think all the data that we have, we can definitely do that. My question is, what's the distribution of software to hardware if we look at the infrastructure bill that the U.S. government has? And if I remember, I think it's like 60 billion to get us straight on the grid pathway. Or what's that the total of the bill? I can't remember.
69.
Anyway,
69.
That's the total of the bill?
Yeah.
Total of the bill. So my question is, how are you guys interacting with building the infrastructure for America in terms of the funding that the government is providing? And can we move where the grid is completely, mostly automated, if you will, in terms of decision making? So therefore, in Texas, when we have a load problem, you don't have to pull it down and you don't have to call anybody on the telephone. It would just do it automatically.
Yeah, so let me answer the first part of that question first, Johnny. So you're right. We're starting to see the U.S. government get much more involved in funding infrastructure improvements. So the Infrastructure Investment and Jobs Act that was recently passed, had 3 or 4 major provisions that were really directed at modernization projects in the electric industry. And we've tried to do a pretty good job digesting those pieces of legislation and getting them out in front of our customers and proposing to them that if they were to apply for funding or to participate in some kind of a collaborative or a group that's going to pursue DOE funding for some type of initiative, that we certainly want to be there helping them, every step of the way. And Andres is aware of a Texas state application that we just expressed our support for, the Texas state application to the DOE that we just expressed our support for. So I'll answer the first part of your question that way, in that we've got a big governmental affairs, industrial affairs organization that studies what happens in not just in the U.S. government, frankly, but governments around the world. And where there's opportunities to partner with our customers and pursue getting some of these investments and exposing the benefits from the research. I mean, we're certainly side by side with our customers looking for that. With respect to this automation, so the second half of your question talked a little bit about we talk about this, descriptive, prescriptive, predictive, autonomous behavior of the electric system. And you've probably seen some graphs. I've certainly got one. I suspect there've been other speakers that have talked about this before. And, today, an event happens on our systems, we can collect all the data and spend a bunch of time describing what happened and why it happened, right? That's descriptive analytics, right? We can try to prescribe what might happen and sort of inform our operating algorithms and our contingency plans. We can do some predictive analytics to say, hey, if this keeps up, we might burn this transformer up, or if this keeps up, we might have a transmission line fail and we've got to do some switching to get ahead of that. But you're asking a question about autonomous behavior.
I'm talking about learning algorithms. Algorithms actually learn. Yes,
exactly right. So machine learning and AI. So I'll say that we believe we're at the forefront in that area. And the low voltage operators in Europe have really presented us some really interesting opportunities to actually apply AI machine learning in those environments where you really lack instrumentation to get the insights that you need. And so this concept of visibility into those systems and to be able to help our distribution operators better, do a better job managing those assets. We like.
Well, I might have something, George, I want to talk to you about. I might bring to you a turnkey solution. We'll talk later.
I'm always up for it. Just don't promote SEC football in our conversation.
I beg your pardon. Go Tigers. Go Tigers.
Llewellyn.
Well, I find this totally fascinating. I think that there's a huge gulf between what George is talking about and what goes small operators are thinking. They're not even talking yet, they're thinking. I think that, and George knows this better than I do, as a veteran of AEP, that utilities are bound very much to the past, and with good reason. They have to keep the lights on. They can't sit and have a discussion and retool, and we'll try doing it differently next year. We'll just shut down for the rest of this year. That's not an option. And I think there's an unrecognized stress there between what the big companies realize has to be done and what the little companies don't yet understand has to be done. I think they have a glimmering of it. And I'd like to go back to what Johnny said, and I do so support that what EPRI invents does not end up in the field. Many decades ago, I used to give an annual lecture speech to the technical information coordinators or something at EPRI. And every year I got the same question, which was, Mr. King, how can we get our companies to adopt what we have invented? They paid for it, it's theirs, but they won't use it. And it could be everything from a better insulator to a computer program in the early days of computers to a coal handling device. And I think that continues. I think the innate conservatism in the utility industry is part of its problem. We use wooden poles because we've always used wooden poles. Is a kind of indication of how they think. And I don't say it critically because they do an extraordinary job. I mean, we have all of these utilities working in sync. We have the most reliable electrical power system. I'm not critical of them, but I think they're going to have great difficulty in adjusting to the challenges ahead, challenges which your company is very critically, obviously aware of.
So Louis, let me react to that. I mean, I'll give my friends at EPRI a plug here. I mean, we've obviously, when I was at AP, was involved with the EPRI organization deeply. They still today do some remarkable research projects with their membership. And, I mean, there's plenty of outreach that EPRI does on solving the most relevant problems that their utility members.
Oh, absolutely. I'm a big admirer.
Yeah. So, but you actually begged a question that I want to answer. And that is, we come up with these solutions. And why can't they be adopted at a faster rate by the electric utilities? And I'll answer that with I guess two ways. First one is that the way that individual solution fits into a portfolio plan. Let's say it's a software solution. The way it fits into a portfolio plan at electric utility may not be intuitively obvious. Just like every other part of an integrated resource plan in an electric utility, the IT investments also follow that same kind of long-range planning. I mean, utilities have historically done a great job forecasting the behavior of their customers and ultimately having the rest of their investments, including supply, frankly, follow the behavior of their customers. We've been in a customer following mode in the electric industry for a long time. I think that's about to get flipped on its ear because those substations that have historically been a big black box whose behavior we can accurately forecast and then do transmission plans and generation supply plans, integrated resource plans to meet the behavior of those distribution load centers, so to speak. All that's about to change when those loads become like 5 to 10 times more dynamic than they've ever been in the past. And so I think you're going to see a much faster uptake by the electric utilities of some of these technologies that are coming out of EPRI and other research projects around the world and get them into their business. But the second answer to that question is really one about business value, right? So the real question is, you're right. We tend to be very, very narrow-minded. Utilities tend to be very focused on the cost and benefit of any investments. I mean, the regulators have sort of built this prudency behavior around any kind of an investment. And what we're starting to see regulators recognize is that when a utility commits to a net zero compliance date by some date in the future, we're going to have to weave in investments for that outcome that have historically been outside of the space of a normal regulatory filing for, let's say, improving the 10 worst performing feeders, for instance, with more capacity or another bay in a distribution substation. So the benefits that accrue to parts of the business that have historically been excluded from these cost benefit analyses, and the benefits to society, right? The benefits to humans that are served by electric utilities, those all become or need to become part of these cost benefit analyses that will enable our utilities to actually make these investments that will ultimately are desperately needed.
I'm glad you call them customers rather than rate players, rate buy, rate. Go ahead. Okay. I'm sorry.
So I have a couple of things, George, and you guys are bringing up some great points. So I read, and I've been approached by several folks where they said to me, and I used to be in the telecom industry before I came to the energy industry. Gosh, don't you remember what happened when we had landlines and then we went to wireless, and somehow we transitioned to wireless and we adjusted to a new way of communicating that is not 100% accurate. There's not 100% reliable, that calls drop, and now you can do voice or text or Instagramming or whatever. And somehow we are okay with this new paradigm. It's a lot more productive. We embraced it, but it does not have the reliability and the predictability of the old system. And I think everybody would agree with that when it comes to voice. So is it possible that we are going to go from the most amazing machine ever built that never fails to one where we're going to have islanding and rolling blackouts and rolling brownouts all the time? And utilities are going to have to be adjusting and segmenting their grids. And this period is going to take not a weekend or a month, but it's going to take years. And we will suffer that because we have the solar rooftop and the power wall, and we can be off the grid for a while, and then we don't feel it, kind of thing. But it's going to really create a chaos, right? And there are two forces that I see on that chaos. One is EVs everywhere. And if you read the latest bill, and Texas just presented their plan to roll out $400 million of EV stations. This is TxDOT. And every Department of Transportation is doing that with the $7.5 billion, 500,000 new EV charging stations, which equate to roughly some 5 million homes if they're all charging at the same time, right? And they're going to be added to the grid overnight, kind of like in the next 12 months. That disruption is tremendous. So George, talk about your guys' vision, because you guys are big on transportation, mass transit, infrastructure like that. How do you see the EVs, 1 million EVs, 22 million EVs in Texas running around? I tell people that the 22 million EVs, registered vehicles in Texas, when they turn to EVs, will require roughly 2,200 gigawatts of energy if they were to charge at the same time. We all know they're not going to charge at the same time. They'll be scheduled, all of that. But ERCOT only produces 80 gigawatts. And there's a big delta between 2,200 and 80 gigawatts. Talk to us about that from the Siemens perspective. How do you see that grid being managed?
So look, you talk about EVs and Andres, I'll share that the utilities that we talk to in the U.S. I think we talk about rooftop solar and the effects of storage and distributed generation. And certainly in some cases in the U.S. it's a major problem. In places where we've seen big penetration of rooftop solar, we're already seeing those disturbances that you're describing, right? We're seeing, let's say voltage flicker, voltage bandwidth violations, like continuously back into the transmission system from the distribution system. Those behaviors are happening right now, but we think the EV challenge actually presents a unique problem for distribution operators. I have an EVS, I have a level 2 charger in my garage. If I put one in and my neighbor put one in, it would largely be a non-event. These are level 2 chargers that are like a 30 amp circuit connected to probably a 25 kVA pad mount outside of my house. It's likely not going to make any kind of a significant impact on the distribution system. But you take a fleet of vehicles that you park at 5 o'clock after they've done their delivery run all day, and then expect to charge those vehicles and have them ready for tomorrow's routes, right? You do that for the postal service vehicles, the UPS and FedEx trucks. You take the metropolitan buses that are driving up and down the streets in our communities, and every time that thing stops at a bus stop to pick up some passengers and drop off some passengers, it drops another couple hundred kW load on somebody's distribution system. Now you've got some distribution control problems, and we think that software is really the only answer for that. I mean, you can try to track the movement of these EVs through your distribution system, but you ultimately have to have software to basically enable the charging of these assets in a way that doesn't disrupt the surrounding consumers. And Siemens is in the middle of this electric vehicle software management space, and we think software addresses that problem.
So you're telling me right now, if we all tried to plug in, like Japan said, that the country will go into a total disarray due to the electric issues that we have. If everybody all of a sudden plugged their EVs and if everybody bought a truck like Andreas, I don't know what he's gonna do with those great sports cars he has. I guess he's gonna get them. Are you telling me then, George, that our dream of plugging in will go up as a nightmare if we all plugged in next year?
Well, so look, I mean, someone joked at a conference once that what would happen if everybody in a high-rise building flushed their toilet at the same time? I mean, I think the same kind of problem happens. I mean, I think the reality is you have to be able to control the impact of EVs on your electric system. And that's the role of communications and software, to be able to properly integrate those EV chargers into your electric system and charge them at times when you've got capacity, manage distributed generation and distributed storage in a way that might offset some of those loads. Right. I mean, this is a brave new world we're about to head into.
Andreas wants to take his truck to school in the morning, charge it up, and then bring it home and let it run his house and never pay another electric bill.
Yeah, he's actually shared that idea with me before.
That's what I'm going to do. So, but here real quick, George, give me your take on another disruptor that I think is maybe the next thing. You know, so cryptocurrency, everybody knows about cryptocurrency, Bitcoin. Crypto mining is the latest way of making money, where you are taking energy through a server in a room that has no cooling needed, right? And you're shooting ones and zeros to create a coin. It takes roughly today 1.8 megawatts to create one Bitcoin. So we in the last legislature in Texas opened the floodgates, and we're inviting every crypto mining company to move to Texas because we want their business, right? And one of the things about crypto mining is that it can actually follow the grid because it doesn't need the issue of chip manufacturing, doesn't need to maintain the yield. It can actually shut down whenever you want to. So it's really friendly to the grid. Now, this is becoming a big floodway into at least Texas. And at Digital 360 Summit, we have the Chief Operating Officer of Denton Electric giving a keynote on how they're handling this, because they have 300 companies in their backyard, right? So what are your thoughts on crypto mining, and how does this take the grid to the next level? How does it help? What are your thoughts?
So look, I'd like to introduce that colleague of yours to our PTI consulting business, right? I mean, at the end of the day, all of those are going to require, all of those new entrants into those utility systems are going to require clear and concise integration into their plans, into their operating plans. Mm-hmm. I mean, to your point, you can't just drop a 1.5 megawatt load into a distribution system, or even a sub-transmission system for that matter, and do those 300 or 600 times without sort of adequately planning for that capacity and how you're going to operate it. Right. You actually mentioned the load following capabilities of these Bitcoin miners, and to be honest, it's a very unique kind of load that, when properly managed, can actually provide a utility some much improved load factor for some of their generating stations. But again, it's part and parcel to let's say an integrated resource plan, kind of a planning engagement that allows these big loads to be integrated into an existing utility system and integrated successfully without causing the kinds of disruptions that we think those might make.
Yeah. Tell us real quick about your second announcement. What is your second announcement?
So look, the grid software announcement we made on May 5th, and I'd encourage folks to go out and research that. I mean, we started talking about this thing about decoding decoding energy, right? The decoding the future of energy. So, what do we see happening in the next 5 to 10 years? And from a grid software standpoint, our part of our narrow part of the world, what's going to be required from a grid control, grid simulation, meter data management, grid resiliency standpoint, places where we make products today. How are those products going to have to evolve? And what do we need to do from a next generation software development standpoint to get ahead of the market? So when the market gets there, we'll be ready with products. But the announcement on June 29th is the Siemens Accelerator announcement. And that's frankly, the bigger announcement for me, that, we as one part of Siemens can be focused on the customers that we've historically served, but Siemens has made a much bigger bet. They said, look, we want to build solutions that meet the most pressing challenges of our customers across all these industries, whether they're in transportation and building technologies, in industrial automation, or in utility operations. We want to meet the most pressing challenges that they face with easy, fast, and scalable software products. And we've acknowledged that we're not going to be able to do this alone. And so the best way to do this is to build an ecosystem that allows partners of ours to basically join us in solving the most challenging problems that our customers are going to face across all these industries, and work together inside of this Siemens Accelerator ecosystem. And we're excited to have announced that at the end of June, and looking forward to standing that thing up here in the months to come.
George, that's a great idea. That's why I have a Microsoft, Microsoft went with open innovation, and Mac went with closed innovation. That's a great idea to do that. And then you can actually move forward. Sorry, Andreas.
No, I was going to say that, I'm hoping that because of the NSF proposal and what we're doing at Texas State Cedar, that Siemens will want to be part of our 64 megawatt solar rooftop farm in our smart energy utilities lab, which is going to work on things like the substation of the future and power electronics of the future and things like that. And that would be a great place to bring all that ecosystem to have a 700-acre playground, life-size playground to do things. Llewellyn?
Well, I find this absolutely fascinating, and maybe one of the best discussions we've had out of many excellent discussions. It points to a future, and I wonder, the future, if you look at it, is always interrupted by invention. Any possibility that these scenarios for the future might be made obsolete by something else? Do you worry about that, George? Do you look at that? That suddenly, what happens if you have blackouts on a consistent basis? People start generating their own in different ways. A household with a generator, a company will try to put in a microgrid. The imperative of having power will be accelerated, not decelerated. So that if the extant system cannot deliver the product, other systems will fill the space. I wonder what are the chances of other technologies. And I'd just like to add as a little caveat to the crypto mining, that there are people looking at ways of getting out of that intensity of electricity. It may not always be the way we do proof of work calculations. I just mentioned that. So that people may be putting in a lot of electric capacity, which may not be needed. I read quite a bit about that, but nothing definitive. Thank you.
So Andres would advocate that when he gets his Ford F-150 Lightning, he could just make his local electric distribution utility irrelevant, right? He could just drive that thing someplace, charge it up, and power his house for a day or two. And when it gets a little low, he can just drive it someplace and charge it up again. I think the reality, though, is this is not an either or scenario. And I'll just give you two quick examples. The most recent one, frankly, is one that we're working with a cooperative utility that's been very interested in developing resiliency of their electric system in the absence of supply, right? So they were in the part of the West where big storms can actually sever a part of think of a cooperative system, long lines, very low customer density. Big storm can come through and essentially isolate part of the system. They've started talking about how can I enable distributed generation on these distribution segments to self-heal, so to speak, to actually create and form little microgrids of their own, while the central distribution system comes back into operation and essentially reforms and reconnects and reestablishes an electric grid. And so there's a lot of work going on in this, in the use of microgrids for resiliency, and I'd like to believe Siemens is right in the middle of that. I cited another example that's maybe a bigger impact at a conference that Andres facilitated a couple of years ago, where we had a chance to describe Siemens Consulting's works for the island of Puerto Rico. When Hurricane Maria came through and essentially wiped out the entire electric system in Puerto Rico, the country had the unique chance to say, to Johnny's point, yeah, this is a 100-year-old electric system that we're dealing with. Well, now it's gone, right? And you have the opportunity to do something brand new using today's technologies. And what the country did was, we had the privilege of working with the Puerto Rican government to develop this concept, but the country basically developed 10 mini grids that essentially leverage the locational generation that exists in those parts of the island. So oil in one part of the island, wind and solar in another, let's say liquid natural gas in another, and allowed those grids to form as those facilities became available. And only when the system became interconnected again, right, the months-long reconstruction of transmission lines enabled the entire island to get the benefit of, say, average cost of generation across the whole island, rather than the peak prices that the wind and solar folks had to pay versus, let's say, the less expensive forms of generation on other parts of the island. So I don't think it's an either or thing. I think we're going to start to see advances on both fronts and allowing these things to work in harmony ultimately to society's benefit.
Excellent.
Absolutely. Let me pause real quick to remind everybody of our Digital 360 Summit is coming up. And George actually was the keynote speaker in 2019. And, we have had all these companies, and Siemens was with us in 2021, again, speaking. And these are the sponsors for this year. We're looking for more, and here is a focus of Texas State Cedar Consortium and the verticals and the labs that we're building. And I want to thank Texas State for sponsoring the Digital Roundtable. George, if you had to share with us, what is the next 6 months in front of you? What's keeping you up at night? What are you working on the next 6 months?
So look, we're working on customer intimacy. I would say that we've got a handful of customers that we're working with globally. We're looking for customers in the U.S. that are interested in working with us on these topics that we've discussed today. We just recently published a white paper, and I'll post it on my LinkedIn page. And Andres, I'll look for you to distribute it to the folks that run this call.
Sure.
It really talks about the challenges that we think distribution operators are going to face in the near term, and we'd love to be part of that solution.
Absolutely. Absolutely. Well, I thank you very much for being with us today, George. You're a great friend. You're in the middle of something fundamentally incredible that we have been dreaming about for the last 40 years or so. And it's finally going to become real. And let's keep at it. And we'll have you again, and we'll keep in touch. And good luck with the football season coming up. Gentlemen, any final thoughts?
And George, remember that you're at the very, very pinnacle of the future of America. So do a great job.
Thanks a lot.
Thank you, George.
And I will email you about the solution that will solve all of your problems. Around electric grid, not around Ohio State football.
Thanks for that.
I think, George, you've certainly cleared up a lot of points in my mind, and I think you've been really a stellar guest on the program this week. And I thank you.
Thanks, guys. It was great to be with you today.
Okay.
Absolutely.
My wife is from Ohio. Go Ohio State.
Yeah. Let's just do it for George. O-H.
I-O. See you guys.
O-H.
Go Tigers. Go Tigers.
All right. Yeah, take us away. Get the guitar. Take us away.
Yes. You like that song, huh?
Absolutely.
The record man, I'm looking for a song I heard today. Somebody was blue singing about someone who went away. Just like me, his heart was broken by a love that used to be. It's a lonely song about a lonely man like me. There was something about a love that didn't treat him right. He'll wake from troubled sleep, call her name at night. Mr. Record Man, get this record for me, if you please. It's a lonely song about a lonely man like me. I speed it up a little bit, but I like that song too. That's an old Willie Nelson song. I like that song.
Thank you, George.
Thank you, George. George, I'm gonna contact you for sure.
All right, see you guys.
All right, and if you want to see some real college football and not a high school, come on down to